with Teradata. Thanks for coming. A couple things. Cell phones, obviously on mute, or airplane, thank you. CEUs, they should be someone at the end of the aisle, as we've been doing all week, once we're done. If this goes, the 45 minutes to an hour, that'll count as a CEU, so we'll see how it goes. I'm going to introduce just quickly from Teradata, Keith Brzezinski. He is from the Boston area. Spent some time at MIT, but he's a big data specialist for Teradata, and we'll let Keith take it from here.
Thank you, Palmer. Can you hear me? Okay. Good morning, I'm Keith. Unfortunately, let's see if this works. Hey, that worked. I've got just like 4 or 5 slides, and the rest of the presentation was actually an online demo, and right now we're actually unable to connect for reasons that are beyond my understanding at the moment. But what I wanted to talk about today was multi-genre analytics, bringing together different kinds of analyses, multiple data sources from different places to get a 360-degree view of the world of the network interactions, and be able to use a discovery platform to drive insights and then present that and surface that for a user in a very repeatable way, capture analytic channels and be able to drive and present those through a number of different platforms. So, we're just going to talk briefly about, why you should care about network security. I think everyone here knows that. Touch on our view of how we look at network security, the kind of dimensions that we operate on, and the kind of the kind of approaches that we take, and then go through selected use cases. So, this is like a 10-second slide. It's big, it's fast. Why is network security important? It's very, very expensive. It's coming at us quickly and frequently. And we've all heard about these different data breaches that have been happening. So I think we've all seen these kind of numbers before during the week. And if you ever have to talk to somebody about this, there's this wonderful website, which I'm going to actually got this one to come up, believe it or not. I'm going to throw this up over here. It's this beautiful little visualization of data breaches over time, some of the major ones. And so just operating down the vertical timeline, you get the more recent ones at the top. And then over here, for example, you can see the Office of Personnel Management. That one right there. I think a lot of people in the room probably are familiar with that particular one. This was their second breach. And that, click on it to get a little bit. It's a wonderful little communications tool. And there is my my demo, unfortunately. So right now, I'm unable to get into my demo. I'm not sure why, but I'll just run through the rest of the material that I've presented, and maybe we'll throw it open for a little discussion, and I'll outline some of the things, some of the approaches that we take. So, excuse me. When we look at cybersecurity, we kind of get a couple of different dimensions that we look at for analysis. And so on the vertical dimension, along the bottom, we've got that endpoint behavior. So what's going on, what programs are being run on the computers, things like virus control, things like partitioning off processes into their own spaces, that kind of thing, doing analysis. And then after the fact, picking apart what was running, understanding what that user behavior was. In the middle, you've got that payload analysis, just looking at things as they come onto the system. And so there you've got rules around things like, what are we going to allow to run, preventing EXEs from coming down, preventing particular known types of attachments from coming down through email, things like that. And then across the top, we've got our network analysis. And so in real time, we've got the network traffic analysis, looking for things like ports to block, detecting DDoSs, things like that. And then on the right-hand side, so on the left-hand side, we've got the real time. What do we do in real time flying as things are flying by? And then on the right-hand side, understanding what's been happening on our networks and on our devices, and then being able to develop insights around that and being able to approach those things. Still coming up. And take those insights and inject those back into the tools that we have. So understanding patterns of behavior and then looking to writing new rules for our real-time intrusion detection tools. And so the intent here was to look at network forensics. To do those things, it's very, very amenable to a discovery platform. So Teradata has a number of different kinds of tools and analytic platforms that are great for approaching different areas in this diagram. And, the discovery platform is a really wonderful tool for bringing together different data sources, sources that are in structured or multi-structured or even unstructured kind of formats, and then integrating those and being able to approach those with lots of different kinds of genres of analytics. You can do path analysis, statistical analysis, sessionization, text analysis, things like that, and be able to do clustering, learned and unlearned, trained and untrained clustering behavior, and stuff like that. So this is where the conversation is going, and then the applications that I was going to walk through, and still might, maybe, not sure. We have a number of different applications, and so there are some themes that come up here in looking at these different applications, and the general themes are around, first of all, bringing together lots of different kinds of data and being able to treat data that is from one source, like an SSH log, for example, in much the same way that one might treat data from another source, for example, logging into health records or physical access or something like that. So, in our world, a log is a log to some extent. So understanding what your users are doing, that's really around integrating a full 360-degree picture and being able to do that. Oh, I went back up. And then taking data from different sources, so being able to, for example, take that physical access entry log and the VPN log, combine those together, and understand where your users are connecting from, different locations, or being able to understand things like the IP logs, where these connections are coming from, and maybe trying to see if you've got someone who is supposed to be in one physical location but might actually be reporting to be in 3 very different IP physical locations over a short period of time. And so that raises interesting flags and things to look for there. And then another theme that we strive for as we go towards implementing this is being able to exist with existing solutions. So Both in the discovery platform, we've got the ability to integrate with, your BI tools of the world, your Tableaus and MicroStrategies and things like that, as well as being able to connect with them using standard, industry standard data analysis tools that are very SQL friendly, so you don't have to go in and learn whole new tools, and then being able to surface those insights and reintegrate those into your existing systems. So you might have something like a Splunk data coming into the sources, and then being able to go and re-inject the information back into, for example, a Scalp XML file, and be able to apply those rules in real time. Those things on wheels. Excuse me. So we also have the ability to come at this data with multiple different kinds of analysis. We'll be able to, for example, look at an integrated view of a customer's or user's behavior, look at their login, look at their badge access, look at their VPN access, look at their application and database access, their activities and behaviors in a number of different web logs, bring those together and generate fingerprints using things like cosine similarity and min-hash techniques to be able to cluster those user behaviors into a number of different individualized fingerprints. And so you can do that at a number of levels. You can do it at the user level. You can then take that out to a role. Let's say you have an analyst role, you have a security guard role, you have a bunch of different roles, different kinds of jobs that people are doing. You could develop fingerprints, maybe a dozen fingerprints of behaviors for each different role, however many there happen to be. And then you start looking for outliers. And when you see those outliers, those become flags for behaviors to investigate. So the behaviors, we might actually be able to demo this. Let's take a look. See if this comes up. I'm going to just take a second here, if you'll bear with me, to load this up. And we'll see about running through it. My apologies for the delay. We just spent about 45 minutes trying about 12 different solutions for getting network access, none of which seem to work very well. But things are behaving themselves to some extent at the moment. So we've got a number of different applications that we've developed to bring these kinds of approaches together. And I'm going to actually skip to the end and start with the application, the network behavior threat application. And so this is, let me just make this a little larger for you. This is a portal that we have called App Center. And behind this, really this is the important part, behind this is an MPP database that has support for multi-genre advanced analytics. So within that platform, you can very quickly and easily bring things together, give them a little bit of structure, organize them in a way that helps you understand them and partition them and sessionize them, and then apply all kinds of different statistical and other analytical tools to them. So you can do network analytics, which is a connection analytics, or sometimes called graph. You can do statistics and text and trained and untrained behavior, naive Bayes, and things like that. So we have an application here, and I'll back out in a second, but within this application, what we do is we just tell it, what the different parameters are, and down here we have a list of, there would be more than one, but right now there's just the one, a list of sessions that we've run. And what we've done here is we've said, we want to look for things that have at least no more than a 25% similarity to the fingerprints that we talked about. So what we're doing here is we've created, and I'm going to try to bring this up again. Here we are. So we've created now we're off the screen a little bit. Hang on a second. We've created an integrated, sessionized view of our user behavior. And so we brought together some our logon logs from our single sign-on server, some application logs from our messaging application and web pages and email and log off and so forth. And then we've created session IDs. So this user here, 350063, session 0, and then session 1 and session 2 and so forth. And then what we've done with that is we have actually grouped those together into similarities. So we've used a cosine similarity data science technique to, what we've done is taken the sequence, log on, web page, message, email, log off, and we've put that into a path of arbitrary length. So with our path sequence tools, we've organized them into paths, and then we take every session and we compare it to every single other session and create similarity scores. And then we use clustering techniques to create clusters of those similarities. And if we have done this correctly, what we see here is the anomalies. And so remember earlier, one more thing here. We put in a 0.25, and so along the way, we use a clustering technique to create clusters of these fingerprints. So for every one of the comparisons, we find the minimum one that it connects to and use some various interesting back-end clustering techniques that I won't go into in great detail. We can talk after the session if you want, to figure out which cluster that thing is closest to. In other words, where's the highest score? And then we look for the lowest high scores that are below 0.25. In other words, things that are way away from the nearest cluster that they could be considered part of. And that's where this average score comes in, and we just did a cutoff of 0.25. And if you kind of scan down here, and I'll make that a little bigger, you can see that we get to this one here, like this sales person who is now uploading a large file, and he had some successful connections to this and some failed connections, and then up here he's uploading more files, and he downloaded some files here. We have two different kinds of employees, sales and technical, and we can start to look at what is going on with those particular folks. And so this like 350040 user, 350426 user over here, which corresponds to that particular record, we can then go in and take a look at the corresponding session there. And let me bring up our behavioral threat detection. So we have in our applications here, and this is a generalized platform for developing analytical channels and capturing them. So we have things around consumer financial and telecom and other things. But we have the ability to do this nice drill down. And in the drill down, we can open up this one here. And it turns out that was for 350426. I'm doing this kind of cooking show style. It takes about 25 seconds to run on the back end. If we want to run it again, hopefully it will behave itself. And we can actually drill down into what that employee is doing. So this is all about that one employee. And so I'm going to bring that one up. And so what we've got is when we do a run here, the developer of this analytic channel tells us or surfaces for us different controls. We can do things like what user it is, or what thresholds are, or what date range it is, or what have you. Make it very repeatable, and this can be integrated as well into a BI tool, or you can use this portal itself to be able to run these on an ad hoc or on a scheduled basis, and then you can. Hopefully, this takes a few seconds to load, and you can expose different kinds of collateral along the way. So you can do, this is a table that just has that particular employee's detailed behaviors in it. You can use, you can surface up a tree graph, or you can do what's called a Sankey diagram. I just want this one to come up right now. Any day now, and we'll take a look at that when it comes up. Let me put this over here. Throw that in there. We'll see you load this up here. So one of the things we could do with this is to take the fingerprints and then look at the sessions, different sessions that the user is doing, different kinds of behaviors, and start building dynamically different fingerprints for sessions depending on how much power we wanted to commit to this kind of behavior or this kind of activity, and then compare those to the existing centroids of the fingerprints sessions for that user or that type of user, or that user when remote versus local, or however you want to partition for your particular user community. So you can develop these fingerprints at different levels and then feed that back into your access control mechanisms, so you can start throwing alerts or intervening in different ways along the way. And this will run eventually. So I'm going to pause here for a second. I didn't mention this was the session was booked as what your data wants you to know. That was the person who was going to present that was not available, and so we're presenting this instead, or trying to anyway. And I blame AT&T for this. Stand by. I can't do it. Yeah. While we're waiting for this, any questions, comments? Okay. I don't know why it's doing this. Okay. So, what? Palmer, what do you want me to do? Oh, okay. Okay. Unfortunately, my connection appears to have failed at this point. I'm not sure why. Aside from it was never running well to begin with. So I'm being reminded that Teradata has some good white papers on multi-genre analytics. There's a wonderful one by a colleague of mine, Mark Turner, on text and graph analytics running at scale, in particular for government, although all of these techniques are certainly relevant regardless of industry, and being able to look at doing things like partitioning out subject matter and being able to detect different patterns of text and attitude in there. So large-scale text and graph analytics for government. Here we are. My apologies for the delay. I'm going to stop apologizing. This is a Sigma graph. You've probably seen similar items. It is super busy. What we're looking at here is each one of these is a session, an end-to-end session. 0 was log in, do some things, log out. 1 is log in, do some things, log out, etc. And the thickness of the line in this graph represents the similarity of that session to every other session. That's why it's so busy, because it is an every-to-every graph, and that's also the reason it took a while to load up. And I will say, this has been my session here for today, is like lots and lots of timeouts. Under normal circumstances, this takes about 10 seconds to load. So what we've got going on here is, over on the left, we've got some controls. And then if you look, you can see these thick lines or thicker lines that are kind of in the middle. And then over on the right, you can see this one little node that is way off by itself, kind of connected by all these little lines and connected out to here. And when you click on it, you can then go into and look at the properties of that node. And you can see, here's the pathway, right? That's the upload large file, and you can, if you go down to the bottom here, you can actually start to look at how that compares to all the different nodes that are surrounding it. But you can get a very quick and easy visual that allows you to very quickly identify, first of all, things that are not close to anything else, and also things that have a very high dissimilarity that are way off on their own. And then down here, I'm going to tweak this up just a little bit, get it back on our screen. We've got the ability to come down here and even just go, I just want to see the ones that are thin. And so you can start to see there are other ones like this one out here that's maybe a little dissimilar as well. Okay, so that is a quick look at, very quickly uncovering some oddball behaviors. And maybe this particular sales guy is leaving and he's trying to download price lists, or maybe he's looking to do something else inimical. So that is that kind of thing. And let me see if... And just for good measure, this one has come up as well. So this actually just shows the data that we just graphed there. for this one particular employee, all the different sessions and all the different activities within that session, along with some basic statistics about it. I have a couple other things to show if the data will cooperate. Down here, we've got some SSH threat log detection. Again, you've just got the number of, some parameters you can put in. These tags are just entered by hand, so you can tag them for whatever you want, of different things you might want to see. Then you can say, how many days am I going to look for? How many suspicious login attempts should I see within a period of how many minutes? So we're looking for 3 login attempts over 20 minutes, looking back over 7 days. And I think we're back to cooking with gas, so that's good. So the raw log data, if we bring that up, it's pretty straightforward stuff. Inside the platform, we've not only got multi-genre analytics, we've also got a set of advanced parsing tools. So while that's loading, I will bring that one up as well. So in this example, we're looking at SSH logs. SSH logs are pretty simple. SSH is a standard technique, a standard protocol that people use to connect to systems. I imagine most of you are familiar with it. It's just people will be, when you look at the logs, you'll see rejected attempt for root, rejected attempt for admin, rejected attempt for root, rejected attempt for root, rejected attempt for root. Once in a while, root gets in because they're supposed to, hopefully, and then various other users along the way. What we're doing here can be done for any other kind of access technique that you care to mention. It could be your VPN access logs, it could be your web application access logs, it could be anything. Any kind of credential log that you care to mention. Okay, so that's the raw stuff. Pretty much what you'd expect to see: date, time, who was coming in. So, this one was, I think, SSL auth D. Some kind of failure codes, some more details around why it failed, things like that. This one was a PAM authentication error. No, you're not who you say you are. Go away. We don't trust you. Oh, user equals bulldog. There's our bulldog. And then this was the actual process that handled that particular request. And then we look at the parser on the back end. The multi-genre analytics has a set of very powerful advanced parsers. So we can, we've got built-in XML parsers, we've got built-in JSON parsers, we've got built-in HTML log parsers, and now we've got an SSH log parser. So we just, one command, we pop those in there. Now we know this was a failed password from this IP address, that was the outcome, and so forth and so on. And we can organize those in some interesting ways. When we do that, we can actually start looking at these from different perspectives. For example, we can say, let's take a look at multiple IPs with from the same address. Multiple requests from multiple IPs with the same username. And then we can look at multiple usernames for the same IP, and you can imagine doing a lot of other things like this. And as you do this, and we'll let those cook for a little bit. And I'll let this one go in the background as well. We can go ahead and start to uncover things. Now, what we're going to see here is we're going to see root coming in from all over the place, multiple IP addresses, root here, root there, root everywhere. And that's not uncommon, of course, these bot armies or even just independent actors who happen to be hitting your public IP address, trying to get in as root or admin or what have you. But if this were a VPN log, you might be interested to see, Bobby coming in from Dayton, Ohio, and then 10 minutes later coming in from Seattle, and then 10 minutes after that coming in from, wherever, DC or the Philippines. And that's a really interesting thing to try to really look at and understand. How is it that this one person with a access credential is coming in from 3 different physical locations scattered across the globe? We actually did a study for a customer, commercial customer, but same kind of idea, looking at just that. And so we were looking at integrating SSH logs with, actually it was VPN logs with badge access logs, and discovered that there was one person who was logging in from a VPN in I think it was Central Ohio, and badging in at the same time in Washington, D.C. It was kind of a little bit south of here, actually, but it was still in the D.C. area. And that raised some red flags, and we reported that back to the customer, and I'm not sure exactly what happened to that person, but it may have resulted in some tightening up of security protocols. So here we have, real quick and easy, we have some path analysis tools, so we can say from this IP address, we've got login of, root, AJ, maybe some other people, all coming in from the same IP address. That's an interesting development if that IP address is known to be one specific device assigned to an individual. Now, maybe that's a kiosk, maybe that's in a VA hospital where you've got doctors logging in and accessing medical records or different medical personnel. But so you might need to dig down on that a little bit to understand more about what the different kinds of devices are and their usage. And so you can then take a look at how that works. And similarly, I have too many windows open here. We have, I think it is, stand by one second. Same username coming from multiple IPs. So now we have, and of course this is an example where you see root coming from just all over the world. And so we get mostly root here because that's the one that is very, very, very common. And again, we can take a look at these different login attempts and understand the sequence of login attempts originating from these different IP addresses. So now we've done some visualization to try to understand, from this IP address, it's a very similar sequence to this one, very similar sequence to this one. It's root, admin, root, or root, admin, root, or whatever. These are actually pretty, these clusters are pretty common ones. This one down here kind of caught my eye. And if we look at that one, we can see that there's another user trying to come in as A. Not quite sure what's going on with that, but A and then root, and then just A, and then just A again with some other different parameters. Maybe that one was twice in a row, and this one was 3 times in a row. And then this one is kind of similar to the other 3 in that it has some commonalities in the way that it's sequenced, but they're pretty far. They're far flung. It's just that happens to be the closest ones there. So, we can start to pick out some visualizations that are useful. Now, if I were running this for real. This is our own internal data that we had, because obviously we're not showing you the customer data. But running this in a real environment, we basically take out or separate out all the root and admin and well-known addresses into their own separate analysis. And you can actually even do things like look at assembling lists of bot armies. So you've got these bot clouds that are out there, and they're doing a coordinated attack or maybe a low-level persistent threat attack. But you can start to look at behavior similarities, developing fingerprints for them, and looking at the ones that are like one another's in the way that they do their timings or the way that they, the different kinds of approaches and attacks that they do. Okay, so let's minimize that. There's a few other things we can do here. We can load that one up. Multiple log data. And let me flip over to, see if we can bring up a different one here. We'll come back down here. Let me get rid of that. Weblog. We'll do the weblog one. So just a few minutes left. I'm going to keep going unless there's comments, questions, just in the interest of time. This one is, let me load this up here and here and here. So what we're doing here is we're looking at some Apache Web Logs. Pretty straightforward stuff. In every kind of situation that we encounter, we always have to do some kind of tailoring or imposition of structure. You get an SSH log, you get get an application log. They're never in standard format. They're often in very similar formats, but they're usually, they come at you at in different kinds of character sets and things like that. So there's always a process of, taking the data, organizing it, structuring it, making it conform in some way so that it's amenable to analysis. Weblogs are kind of the exception. With Apache Web Logs and the weblog parsing utility, all you need is the format string. If you have the weblog format string, you plug the weblog format string in, and you get out this beautifully formatted, information out of your weblog session. In this application, we can tell it the number of days to look back. We're looking back 7 days. We can tell it how many edges to show. We can give it a file type exclusion. I don't want to look at requests for JPEGs and other images. If somebody pulled a CSS file, I don't care. That's just sort of part of pulling a page. So I'm not, I can give it some exclusions, and I can also tell it, here's what I consider to be a session. So sessionization, pretty straightforward stuff, is usually based on a timeout of some sort. So somebody is, in the commercial world, somebody's shopping for shoes. They're shopping for shoes. They put things in their basket. They wander away for 2 hours. The basket expires. Their session is timed out. If there's no activity within a certain period of time, you just typically set a threshold and you say, that's our timeout. And so here we have a half-hour timeout in this analysis to see what we've got. So this is, I'm not going to show you the source weblog. I think, those are something we can look at separately if we need to. But this is what we get out of our sessionized weblogs. Pretty straightforward. Here's the host it came from. It was a post or a get. Here's the URL that it hit. Some information about what was going on the other end. Was it, a Mozilla? Was it a IE or whatever, Edge browser? And then, the final status, was it successful? Was it not successful? the packet size. And then over here, we've got this rule ID and description. And what we've done is we've integrated with in this example, we've integrated with an open source utility called Scalp. And Scalp is a threat detection web log analysis tool where you can plug it into a set of rules. The rules are an XML file that we just drop into the database. And it automatically applies the rules and figures out whether or not this rises to the level of a particular threat based on these rules. And so the outcome of this analysis could lead very quickly and easily to developing new rules or tailoring the existing Scalp rules to be able to go back into your tool and be able to do more threat detection or tune it for reducing false negatives or false positives. You want to reduce false everything, but in this case, false positives. And some other information over here, as well as the original data that we started with. So is this our... So we've done a little bit more of this detailed information. We're looking at sessions that are coming out of these different IP addresses. I'm not going to spend a lot of time on this, but you can see we've now gone in and clustered the sessions and taken a quick look at different kinds of interactions. So you can see this, the sequence of what somebody went after, administrator index, and so forth. That was a pretty straightforward session, quite frankly, and other sessions that are similar around it. This particular visualization shows the similar sessions called neighbor view. So you clicked on a session, and it brings up the ones that it's connected to in this visualization. And remember the number of edges to show. So this is the top, I think, 25 around it, something like that. When we go back and look at here, say maximum edges. Total maximum edges 2,000 for the overall picture. So we don't end up with the massive maze that we had earlier. There's a lot more fun things in here. Given a better connection, we might be able to take a look at some more things. I'm going to pause here for Q&A. I think I've run over my time a little bit. Comments, questions, sneers, jeers, abuses? Anyone? Is the microphone up in the middle for anyone who has a question? This is the stop time. Thank you very much.
There you go. So again, under constrained network circumstances, so here in the real world. But listen, Keith, thank you for coming down and providing, again, a more detailed look at what's going on behind the scenes. I think this theater's kind of started at the top with the reasons for cybersecurity and from the user side. Now we're back into the defenders and into what's possible, with visuals to help, be a defender. So, again, thank you for your attention, and we appreciate. There's a few white papers here if you have interest about Teradata, and we can get you some more interest around the Cyber Apps Center environment. In fact, we're doing some things here in Washington in some labs with DHS, so a lot of these things are just being vetted out. If you're local and would like to stay after, I can give you a card and get you a shot at looking at some of those things sort of real and live in some of the labs around town here. So, all right, thank you very much.